When running the FGM Fluxgate Magnetometer software for the first time after installation, you will see this splash screen. All the files are set to their default settings, and the program needs to locate the microcontroller that controls the Fluxgate Magnetometer. And this could be on any USB port. So the first thing it does is it knows that you are running the application for the first time. So when you see this dialog box, just simply click your mouse inside the program window, and after a few moments it should find the COM port. Now while you're doing the search, if you have the Bluetooth option with your kit, please do not pair it at this point. It sets up the Bluetooth as a virtual COM port, which can be mistaken for the hardware COM port. So we've already connected, it has found it, and it has saved that information to a config file. At this point, if you have the Bluetooth option, you could now safely pair your radio, which I'll demonstrate now. If your FGM unit is pre-installed with the optional Bluetooth radio, there's two ways you can go about this. Once you've made an initial USB connection, you can manually add the device by going to your quick launch bar and open your Bluetooth settings. First thing you want to do is open your Bluetooth settings and make sure that your radio is discoverable. So open settings and make sure that under discovery, allow Bluetooth devices to find this computer is checked. It is. Now that that's taken care of, go back to your Bluetooth settings and add a device. It's going to go out and search for any USB devices that are nearby. Your radio has been pre-programmed for you and should be named FGM3. So once your Bluetooth adapter recognizes the radio, just highlight FGM3 and click Next. You'll then be prompted to enter the device's pairing code. So click on Enter the device's pairing code. The code is 0000. Click Next and it should find your radio and install the drivers for it. Once it has installed the device driver software, you can begin using your FGM via Bluetooth. Typical range is about 40 feet. Next, I'll show you the alternative way to connect to Bluetooth. Alternatively, you can connect to your Bluetooth device through the software. The only thing you need to do is make sure that your Bluetooth device is discoverable. So in your Bluetooth settings, open your settings and make sure allow Bluetooth devices to find this computer is checked. One thing to note is if the unit has been powered up for a while, the Bluetooth radio will time out after a few minutes. So if it does not discover it, just lift the lid and push the reset button on your unit. This will reset the Bluetooth radio. So with the application up, and I am currently in USB mode, and the radio is not paired yet, but all you really need to do is click on the Bluetooth icon. At this point, the USB connection will be severed, and it is searching for a compatible Bluetooth device. When it finds one, it will notify you and then proceed to prompt you for the pairing code. This can take up to a minute. It has discovered our Bluetooth device and wants to connect. So click on the dialog box. Enter the pairing code of 0000. Click Next. Congratulations, you are now connected via Bluetooth. After a few moments, the SPP serial service message will disappear. The next time you run the application, it will remember these settings. If you ever need to use the COM port utility again, press the F2 key. If you need to reset the application to its default settings, use the F1 key. Now we'll go over some of the software's features, starting at the top left, and we'll work our way to the bottom. First thing you'll want to do after installing the software and establishing a connection is give your station a name or an identity. Typically, this is the nearest major city, and you can alternatively add your latitude and longitude. To do this, inside the program window, just press the F3 key on your keyboard. Pressing the F3 key will bring up a dialog box, which will allow you to enter your nearest major city. If you wish to enter your general latitude and longitude, you can click on the link, which will take you to magneticdeclination.com, which will give you your exact latitude and longitude. So I will put in my location. And please note that no commas can be used in this text field. If you do use commas, it will alert you. And I will enter my general latitude and longitude. 35 degrees north by 80 degrees west. Once you've done this, hit submit to save your changes. If you've made a mistake, you can click the clear button. In order for these changes to take effect, you must exit the application and restart it. Whenever exiting the application, please always use the large red X instead of closing the window with the Windows Close icon button. Doing so will not save some of your data, which is why I suggest using the program's exit button. Now let's cover some of the other information found at the top of the application. As you can see, our station location, latitude and longitude now shows up under Fluxgate Magnetometer station. Your Windows system time is automatically converted to UTC or Universal Time. The timestamp below your location indicates the exact time when the plot was started. It is a 24-hour variation plot of the H component of the magnetic field. When the plot is first started, the sensor is zeroed out to half field. So your first few plots should be on the zero reference line. Throughout the day, plot variations above or below the zero reference will be plotted. Positioning your mouse anywhere in the plot area will give you the time and the value of change. So this one tiny pixel that it has plotted, which it plots one value each minute. I can hover my mouse over that value and get the time and the change in nanoteslas. At the top right, you have 4 sensitivity settings. Below that, you have an auto reset. The auto reset function will automatically recalibrate and zero out your Fluxgate Magnetometer at the beginning of a new plot. So, at the end of a 24-hour period, if you want your sensor to be recalibrated and zeroed out, check this box. If you would rather it not be zeroed out, leave it unchecked. And then below that, you have a real-time clock. Next, we'll get into the raw data and the user interface. There's a wealth of information at the bottom of the plot in this raw area data and user interface. The battery icon keeps a close eye on the 5-volt status of the entire unit. If the voltage drops below 5 volt, it will alert you by turning red. Next to that, you have a communications icon. This will either be a USB icon or a Bluetooth icon with a check or an X indicating if a connection is present or if the connection is lost. Above that indicates the mode that you are plotting in, and there's 2 choices. You can choose to plot the digital data coming off of the ASIC inside the unit, or you can plot the analog to digital values. Both have weaknesses and advantages, which we'll go over later. In your raw data section, you've got the frequency that's coming back from the FGM sensor, the A to D value, and the digital value. These are the values that are being plotted. To the far right lower corner, you have a K-index gauge. The K-index is a geomagnetic storm numbering system, sort of like the Richter scale. It is calculated every 3 hours and is based on the change in nanoteslas over 3 hours. Every 3 hours, the gauge will upgrade given the current estimated K-index. As well as updating the gauge, an estimated K-index will appear in this empty text area at the top. Also, in between each 3-hour time ticks, you will get a color-coded number indicating the K-index and the intensity of any storms. Now to go over the user interface buttons. The first button will simply take a snapshot of the current plot. The image will be stored as a PNG file in the program's working directory under a folder named Snapshots. All you need to do is click this button. Now it has made a time-stamped screenshot that will be in the Snapshots folder. The next button will reset the plot. It'll wipe it clean, and if the auto reset button is checked, which I will check that again, this will start from scratch, erase all data, calibrate the sensor if auto reset is selected, and start a new plot. The next button allows you to, on the fly, change between plotting the analog data coming back from the unit, or you can choose to plot the digital data. This will not reset the plot. Some advantages are, because of the 10-bit analog to digital converter, using the analog input method will give you a bit more resolution and headroom at the cost of the values jumping slightly, while using the digital input will give you a slightly smoother plot with a bit less resolution. Note that when you exit the program, all of your preferences are saved and reloaded the next time you start the application. We've already been over the USB and Bluetooth icons. This allows you to switch communication modes on the fly. But do note that if you change communication modes, this will reset your plot. The next button will set your sensitivity, and there are 4 settings. Right now, the unit is in its 3rd highest sensitivity setting, which is a range of plus or minus 250 nanoteslas. Clicking this button will change the sensitivity, and this will not reset your plot. So now I'm in the highest sensitivity setting, which is plus or minus 150 nanoteslas. Clicking it again will go to its lowest, which is 1000 nanoteslas. And there is a medium setting of 550 nanoteslas. If you're using the FGM3 sensor for geomagnetic storm monitoring, I would suggest the highest setting of 150 nanoteslas. If you're using the FGM3H and your plots tend to go off scale or saturate, you may want to try a lower setting. The next button will calibrate the unit and simply zero it out to a reference. So when I click this, we should see the digital value go to 256 or half scale. The data is updated every 10 seconds. So it got its new data and it is now zeroed out. Any plots beyond this point will be based on a zero reference. The calibration button can be used at any time without resetting the plot. Finally, the output folder button will allow you to choose any location on your hard drive, network, or even a cloud-based storage. Clicking it will open a dialog box asking where you want your plot images to be saved. By default, the plot images are saved in the program's working directory under exported plots. But you can change this to your liking. Personally, what I do is maintain a Dropbox cloud account that is synced with my file system. So I can direct my output folder to that Dropbox folder. And that way my images are automatically updated to the internet each minute. Plot images are updated once a minute with a final plot with a timestamp exported every 24 hours. And finally, the last button is the exit and save button. Please use this button to exit the application rather than using the close window icon at the top right. This ensures that all your preferences are saved before the application closes.